Welcome to Learn Mathematics with Moni. Get your books and pen and get ready to learn.
You are welcome to class. Today we'll be learning the addition and subtraction of fractions. It is possible for us to have fractions with same denominators. Let's start with same denominators. When the denominators are same, the work is straightforward. Like when I have 1 over 5 plus 2 over 5. Since both of them are taken out of 5, this is 1 out of 5, and this is 2 out of 5. They are fractions from the same size. So we just go ahead to add the numerators. That is 1 plus 2, everything over 5. So both of them are over 5. And in this case, this is equal to 3 over 5. It is that simple. And if it is subtraction, let's say I have 4 over 7 minus 2 over 7. This is also very easy and straightforward. The denominators are the same, which means they are fractions that are taken from the same size. So in this case, we have 4 minus 2, the numerators, everything over 7. 4 minus 2 is 2, and that is just 2 over 7. But there are some cases where we have denominators that are not same. When the denominators are not same, different denominators, how do we work with that? When we have different denominators, our target, our objective, our goal is to make the denominators the same first, so that the addition or subtraction can be a lot easier. Let's see a situation where I have 1 over 3 plus 2 over 5 on equal denominators. I have 1 over 3 plus 2 over 5. I'm going to be teaching you about 3 methods of handling this. The first method is direct multiplication of the denominators. 3 times 5. Look at it. 3 times 5. Multiply the denominators. Then after that, the next thing you do is your left diagonal. 1 times 5 plus your right diagonal. That is 2 times 3. In this case, I have 1 times 5 is 5 plus 2 times 3 is 6 over 3 times 5 is 15. So 5 plus 6, that is 11 over 15. That is one way of doing it, and it's very fantastic. Another way of dealing with this is to use the equivalent fraction method. We want to make both of them to have the same denominator. Plus 2 over 5. We'll be making use of the LCM. The smallest number 3 and 5 can divide is 15. That is the LCM. LCM of 3 and 5 is 15. So we are using 15 as the common denominator. So I'm going to be asking myself, what can happen to 3 that will make it 15? That is, 3 times 5 will be 15. Because this is 3 times 5, I will also multiply the numerator by 5. What can happen to 5 to make it 15? That is 5 times 3. Whatever you do to the denominator, you must do to the numerator. So this is 3 times 5, 15, and 1 times 5 is 5. That means 5 over 15 is the same thing as 1 over 3. Plus 5 times 3 is 15, 2 times 3 is 6. That means 6 over 15 is the same thing as 2 over 5. So I have 5 plus 6 equals to 11 over 15. That is another method of doing it. The third method I'll be sharing with you today is still the equivalent method, equivalent fraction method. It's just in another form. Look at it. We have 1 over 3 plus 2 over 5. We know that the LCM of 3 and 5 is 15. So I'll be using it as the common denominator. Now, how many 3 can I get from 15? That means 15 divided by 3. 15 divided by 3 times 1 plus 15 divided by 5 times 2. This means how many 3 can I get in 15? That is 5. 5 times 1 is 5. And that is what I have here. 15 divided by 3 is 5. 5 times 1 is 5. Plus 15 divided by 5 is 3. That is how many 5 can I get in 15? 3. 3 times 2 is 6. 15 divided by 5 is 3. 3 times 2 is 6 over 15. 5 plus 6 is 11 over 15. These are 3 different methods, but all are going to give us the same thing. Let us look at subtraction or fraction. I will also use the 3 different methods with unlike denominators. Yes, let me quickly say this. Anytime you see me cleaning the board is a time for you to share my video. Share to your friends, cousins, classmates, neighbors. Do you have enemies? Even if you have enemies, you can share to them. It is also a time for you to comment. Make sure you comment, you write a comment on my video. It helps the algorithm push my video to other students or parents that need it. Let's go with unlike denominator. Different denominators. We want to see subtraction with different denominators. And I'm going to be using the 3 methods I use for addition. Okay, let's see this example where I have 5 over 9 minus 2 over 3. 5 over 9 minus 2 over 3. Okay, let me change this to 7 over 9. There is a reason for that. 7 over 9 minus 2 over 3. The first method that we use is the lazy guy method. Direct multiplication of the denominators, that is 9 times 3. Then my left hand side, the diagonal to my left, that is 7 times 3 minus my right diagonal, that is 9 times 2 or 2 times 9. So let us do this. 7 times 3 is 21 minus 2 times 3 is 18 over 9 times 3 is 27. This is giving me 21 minus 18 is 3 over 27. I won't leave my answer this way because 3 is a common factor of 3 and 27. I will reduce it to the lower term or the lowest term. 3 divides 3 once. 3 divides 27 9 times. That means my answer is 1 over 9. That is the first method. Okay, let's see the second method. I'm going to be using the same question to use the second method. This second method, I'm going to be exploring the LCM. The LCM of 9 and 3. The smallest number 9 and 3 can divide is 9. So we are going to employ that as our common denominator. So that I will make each of these fractions to have a denominator of 9. This is already having a denominator of 9. So that is just 9 times 1 and 7 times 1. This is having a denominator of 3. I want it to have a denominator of 9. 3 times 3 will give me 9. So I'll multiply the numerator also by 3. Whatever you do to the denominator, you must do to the numerator. Whatever you do to the denominator, you must do to the numerator. 9 times 1 is 9. 7 times 1 is 7. Minus 3 times 3 is 9. 2 times 3 is 6. So that I have 7 minus 6, 1 over 9. And that is just the same thing we have here. Let us use the third method. The third method, I'm still going to use the same question so that you can be able to compare and choose the one you find easier. I'm using LCM of 9 and 3 as well. The LCM of 9 and 3 is 9. So I'm going to be using that LCM as my common denominator. So, for me to have my numerator, I'm going to ask myself, how many 9 can I get from 9? That is 9 divided by 9. Whatever I get as my answer, I will multiply it by the 7 times 7 minus 9 divided by 3. That is how many 3 can I get from 9? 9 divided by 3. Whatever answer I get, I'll multiply it by 2. Multiply by 2. So that I have 9 divided by 9, 1. 1 times 7 is 7 minus 9 divided by 3 is 3. 3 times 2 is 6 over 9. 7 minus 6 is 1 over 9. And with that, using 3 different methods, we got the same answer. I hope you will be able to use these 3 methods also. Can you pause? Okay, sorry, I thought that was actually paused. So, using the 3 methods, you can see we got the same answer. You are free to choose any of the 3 methods. You are also free to use all of the 3 methods interchangeably. Let us look at when we have mixed numbers. That is addition and subtraction of mixed numbers. This is also a time for you to write another comment in my comment section. If you have not shared my video, this is a time to share. This is a time to like. If you have not subscribed to my channel before, this is a time for you to subscribe. Go ahead and do that now. Okay. Let's say, for example, I have 3 wholes, 1 over 6 plus 1 whole, 2 over 3. And I want to add them together. I will start by adding the wholes. The whole numbers are 3 and 1. 3 plus 1. Then I will add the fraction 1 over 6 plus 2 over 3. So let's go. 3 wholes plus 1 whole. That is 4 wholes. 4 whole number. Now for the denominators, I can decide to use the equivalent fraction. I can also decide to use the LCM method. Let's use the LCM method. The LCM of 6 and 3 is 6. LCM of 6 and 3 is 6. So I'm using it as a common denominator. How many 6 can I get from 6? That is 6 divided by 6 is 1. 1 times 1 is 1. Plus, how many 3 can I get from 6? That is 6 divided by 3. That is 2. 2 times 2 is 4. That means I have 4 wholes, 4 whole number. 1 plus 4, that is 5 over 6. I hope this is very clear.
You need to pause right now. Go right now and subscribe to my channel. Click on the notification button so that you can be notified anytime I drop new lesson. Thank you.
Let's take another example. Let's look at an example where I have 14 wholes, 2 over 5 plus 3 wholes, 1 over 7. We want to add them. We are adding the wholes first. That is 14 plus 3. Then the fraction, I have 2 over 5 plus 1 over 7. 14 plus 3 is 17 whole number. Now for the fraction, I want to use equivalent fraction method as well. The LCM of 5 and 7 is 35. And I'll be using 35 as the common denominator. For 5 to become 35, that means I'll have to multiply it by 7. Whatever you do to the denominator, you must do to the numerator. So the top also will be multiplied by 7. For 7 to become 35, that means I have to multiply it by 5. Whatever you do to the denominator, you must do to the numerator. So I have 5 times 7 is 35. The numerator, 2 times 7 is 14. Plus 7 times 5 is 35. The numerator, 1 times 5 is 5. So that we have as our answer 17 wholes, 14 plus 5, that is 19 over 35. It is familiar and easy. Let us look at subtraction of mixed numbers. Okay, subtraction of mixed number. Let's look at the first example where I have 8 wholes, 3 over 5 minus 5 wholes, 2 over 7. Let's look at this situation. I will have to subtract the whole numbers first. That is 8 minus 5. Then I have 3 over 5 minus 2 over 7. Let's subtract the whole numbers first. 8 minus 5 is 3. the fractions, I want to subtract it. I want to do the other method. That is, the multiplying the denominators first. 5 times 7 for the denominators. Then the numerators. My left diagonal first. That is 3 times 7 minus my right diagonal, which is 2 times 5. You remember this method from the beginning of the class? It is still valid. So I have 3 wholes. 3 times 7 is 21 minus 2 times 5 is 10 over 5 times 7 is 35. That is equals to 3 wholes. 21 minus 10 is 11 over 35. And this is a very correct solution. Let's see another solution. Another example. It is possible for me to have 4 wholes, 7 over 10 minus 3 wholes, 3 wholes. Let me have times 5 times 5. Okay. Let me make it over 3. 2 over 3. There is something I want to make you see here. The whole numbers are to be subtracted first. 4 minus 3. Then the fraction. 7 over 10 minus 2 over 3. Let us try to subtract that. 4 minus 3 is 1. The LCM of 10 and 3 is 30. How many 10 can we get from 30? 3. That is 30 divided by 10. 3. 3 times 7 is 21. Minus. How many 3 can we get from 30? We have 10. 10 times 2 is 20. So that our answer is 1 whole 1 over 30. I believe this is simple and understood. But there are some cases with subtraction of mixed numbers where we find it difficult to subtract the fractions from each other. Let's look at such situation and how to handle it. Go now and write "Thank you, Miss Moninola" in the comment section. Thank you, ma. Write it in the comment section. Say something in the comment section. Yes, you're welcome back. This is the third example we are seeing for subtraction of mixed numbers. Let's see a situation where we have 6 wholes 1 over 3 minus 4 wholes 3, let me pick 5 over 9. Let's see this situation. We have to subtract the wholes first, just like every other example. 6 minus 4. Now we have to subtract the fractions. 1 over 3 minus 5 over 9. 6 minus 4 is 2 wholes. I want to do the direct multiplication for my denominator. 3 times 9 is 27. Now my diagonal multiplication, we start with the left. 1 times 9 is 9. Let me just write it straight away. 1 times 9 is 9 minus the right diagonal. That is 5 times 3, which is 15. And this is the situation I'm talking about. Look at the numerator. You have 9 minus 15. You can't go further from here because you can't say you have a negative numerator. So you are going to abandon the solution here. You will leave. Once you have situation like this where you cannot subtract the numerator without having negative, you leave it there and use another method. There are 2 other methods you can use, and I will quickly share both of them with you. The first I want to share with you is this: 6 whole number 1 over 3 minus 4 whole number 5 over 9. Now I have seen that 1 over 3 is smaller than 5 over 9. I can't subtract them. So I will pick 1 out of this whole number. This 6 is actually 5 plus 1. Do you agree 5 plus 1 is 6? Yes. This 6 is 5 plus 1. 1 over 3 minus 4 wholes 5 over 9. This 1 that I have removed from the whole number, I'm going to convert this entire one, my 1 whole number 1 over 3, I'll be converting it to improper fraction. So that I have 5 whole number. Let's convert this to improper fraction. 1 times 3 is 3. 3 plus 1 is 4 over 3. Minus 4 whole number 5 over 9. Now we want to do the subtraction. 5 minus 4 for the whole numbers. And the fraction 4 over 3 minus 5 over 9. I will still use the method I use here. Let's go. 5 minus 4 is 1. The 3 times 9 is 27. The left diagonal, 4 times 9 is 36. Minus the right diagonal, 5 times 3, that is 15. You can see that we have actually increased the first fraction by removing 1 out of the whole number and adding it to it. So now I have 1 whole number, 36 minus 15, that is 21 over 27. I won't leave my answer like this, because 3 is a common factor of 21 and 27. So 21 divided by 3 is 7. 27 divided by 3 is 9. So that my final answer is 1 whole number 7 over 9. I hope you understand this. Let's take another example very similar to this situation where we can't subtract the numerators. Okay, I'm calling this example 4 under subtraction of mixed number. Let's say we have a situation where we have 14 wholes, 13, okay, 14 wholes. Let me pick a case like 1 over 7 minus 10 wholes and 3 over 4. Let's see this situation. Subtracting the whole numbers first. 14 minus 10. Then the fractions 1 over 7 minus 3 over 4. 14 minus 10 is 4 wholes. Then the denominator here 7 and 4. I want to use LCM method now. The LCM of 7 and 4 is 28, and I want to use that LCM method. So I take the LCM as the common denominator. How many 7 is in 28? 4. So it means it is 7 times 4 that will give 28. If the denominator is 7 times 4, the numerator is also 1 times 4. 4 times what will give 28? 4 times 7. If the denominator is 4 times 7, the numerator will be also 3 times 7. So let's see. 7 times 4 is 28. So 1 times 4 is 4. Minus 4 times 7 is 28. 3 times 7 is 21. This is another situation like example 3. We have 4 minus 21. We cannot do the subtraction, so we leave it. We leave this method. We leave. When we have left, I'm going to teach you the second method you can use now. The second method is to convert the entire question into improper fraction. Look at this. We have 14 whole number, 1 over 7, minus 10 whole number, 3 over 4. You can convert the entire question into mixed improper fraction, rather, where you have 14 times 7. 14 times 7, 7 times 4 is 28. 7 times 1 is 7. Plus that 2, that's 9. So we have 98. 98 plus 1, that is 99 over 7. 14 whole number, 1 over 7 gives 99 over 7. Minus 10 times 4, 40. 40 plus 3, 43 over 4. So now, we have to do the subtraction. The LCM of 7 and 4 is still 28. So let's see. The LCM is still 28. 7 times 4 is what will give us 28. So the numerator will also be times 4. 4 times 7 is what will give us 28. So the numerator will also be times 7. So let's see. 7 times 4 is 28. 99 times 4. 99 times 4, let's see that. 4 times 9, 36. Remaining 3. 4 times 9 is also 36. 36 plus 3, 39. So we have 396 up there. Minus 43 times 7. Let's treat our 43 times 7. 7 times 3 is 21. We write 1 and save 2. 7 times 4 is 28. 28 plus 2 is 30. That is 301. So we have 396 minus 301. That is going to be giving us 95 over 28. We won't leave our answer as improper fraction. We will convert it to mixed number. So, how many 28 can we get from 95? About 3 of it. 3. 3. And what will be the remainder? Let's see. 28 times 3. 3 times 8 is 24. And write 4 and save 2. 3 times 2 is 6. 6 plus 2 is 8. That's 3 of 28 gives 84. When we remove 84 from 95, you'll be left with 11 over 28. That is another method you can use when the first fraction is bigger than the second fraction. I want to repeat the method I used in number 3 so that you can get it. Or you can do this. This is an alternative method. Instead of changing the entire of 14 whole number 1 over 7 into improper fraction, you can actually pick only one out of the 14. So 14 whole number 1 over 7 minus 10 whole number 3 over 4. I don't want to change the entire. I just want to split this 14. 14 is 13 plus 1. So I have 13 plus 1, then 1 over 7 minus 10 wholes 3 over 4. This is still my 13. I will convert my one whole number 1 over 7 to improper fraction. 1 times 7, 7. 7 plus 1, 8. That is 8 over 7 minus 10 wholes 3 over 4. Subtracting the whole numbers now, I have 13 minus 10. That is 3. Now, the LCM. The LCM of 7 and 4 is 28. How many 7 do I have in 28? I have 4. 4 times 8 is 32. Minus, how many 4 do I have in 28? 7. 7 times 3 is 21. So the result of that is going to give us the whole number, which is 3 wholes. 32 minus 21, that is 11 over 28. You are free to choose the method you think is easier for you or you understand better. But I can tell you that using this other method is actually easier. I will see you in the next class. Remember to share my video, write a comment on it. You can even ask a question. I will definitely respond to your question. Don't just forget it in this class. Go ahead, solve several problems on the topic so that you can be sure you know it. I'll see you around.
Thank you for learning mathematics with Moni today. Do you know you are free to share my videos with your classmates, your colleagues, your friends, your cousins? Do that right now and be a blessing to them and to me.